Okay, so we're going to find the possible roots. That is not the same as find the roots. If it just said find the roots, we'd have to factor it. And we've told you like 6 different ways of factoring, one of which is synthetic, which we're going to remind you about today. All right, but back to the possible roots, that's FCon over FCO. Now, before I started this video, I reminded kids that little formula. Be honest, how many of you would have had that down? You knew that that was how to do this problem. All right, that's very few of you. So thankfully, I reminded you that that's how you do it. Factors of the constant, which is that number. And so plus and minus needs to be in your answer. Doesn't have to be on that first number, but it could be in front of the whole thing. And then the factors 1 and 2 and 4. And then on the other one, it's plus and minus. But again, we really only need that once in our final answer because it's plus and minus of everything. And the factors of the coefficient is that number. That's the lead coefficient. And that's a 1 and 3. And so then you take everything divided by everything. So 1 divided by 1 is 1. So I could just say 1. And I'm going to have plus and minus in front of this. Comma. 2 divided by 1. Oh, wait. I could do the 1 divided by 3 next. I think I'm going to do it that way. 1 divided by the 1 and 1 divided by the 3 makes 1/3. And 2 divided by the 1 is 2. And 2 divided by the 3 is 2/3. And 4 divided by 1 is 4. And 4 divided by the 3 is 4/3. And there's all of your answers. And I said there was at least 8. Oh, there's way more than that. 2, 4, 6, 8, 10, 12. There's 12 answers. All right. Now, once you've done that, now you know which things could possibly work. And then you could do synthetic on it. I'm now going to give you one that's a typical hard synthetic problem. Yesterday we worked on the R2s, which were kind of like the relatively easy skills. Today we're doing the R3s. All right. So here's a good challenging. You know what? I think some of you might have even forgot even how to do this at all. So let's do this first. 1, 4, -2, question mark. Draw the line. Drop it like it's hot. Everybody go through this and figure out what the question mark would be. If you followed the synthetic rules, what would that question mark have to be be able to make it have a remainder of 0 at the end? Because we want it to have a remainder of 0. This will be a good warm-up to one of the hardest questions you'll have on either the cumulative or the final. All right, so you drop it like it's hot, and then you multiply. 3 times 3 is 9, and then you add. 9 and 4 makes 13, and then you multiply. Holy cow, this is getting huge. 13 times 3 is 39, and then you add 37, and then you multiply. 1 on 30 times is 90, and 3 times is 21, so it'd be 111, I think. Is that right? Or did I make a mistake in there somewhere?
Drop the 1.
Uh-oh. Okay. Oh, that's so weird. I dropped a 1 and it became a 3. You're right. 1 times 3 is 3. Okay. Sorry. 1 times 3 is 3. Add them. 7. Multiply them. 21. Add them. 19. Still going to be big, but it's not going to be that big. Okay, so I'm going to make sure I didn't screw this up. 1 times 3 is 3, and then add them, and then multiply them, and then add them. Yep. Okay, so then this is 60, but take away 3, which would be 57. Is that right? So then the last number would have had to have been a -57, because these two will cancel each other out at the end if it's going to work. And then you'll get a remainder of 0. That's the R. Okay, now the hard part. What are the factors? You got to be able to interpret your answer. Do you remember that part? Be honest. How many of you remember that part and you're good? Okay, that's about half. I want to see, just dice of destiny, if a random kid remembers how to do this. It's row 4. Jonah French. That's you. What are my factors?
Bring down the 3 to make x plus 3.
Yeah, you're close. X minus 3. It is a very common mistake. This is called a zero or a root. What it does is it makes this equal 0. See how that would work then? Okay, and then the other part?
Then you bring down the other numbers.
Yep.
19x.
So it's
7x squared.
nope. Good thing we're talking. That's a 19 regular. It doesn't have an x. This one is the constant. See, we wall off the r. The 19 doesn't have any x on it. This has the x, and this has the x squared. And then since they're positive, I put pluses. And there we go. Okay, you can see it was a good thing we talked about that. So that is factored. Did you even look to see if this could be factored further? Did you? Because if you looked, then you win. It doesn't actually factor, but you should at least looked at it and thought, I wonder if I can factor that. Because otherwise, tons of kids will get to the end of the test. They will have factored it part way, but it didn't factor it all the way. Like, for example, let's say you had this. Do you get how a kid, after doing a whole bunch of work, gets to there and could easily forget the final step? And what's wrong with that? This can factor into x plus 1 and x minus 1. Can x plus 3 factor more? No. Okay. So now that I've reminded you how the synthetic works, I'm going to give you a actual hard level, R3 level. Can you use synthetic? Now here's your challenge. If x equals -3 is a 0 of x to the 4th plus 3x to the 3rd plus 6x squared plus 18x, factor it. And I would suggest strongly that you use synthetic, because you want to practice synthetic, because you're going to have to use synthetic. If you're like, but I thought you were going to give us numbers in a little box like this. You have to make your own box and your own little numbers. All right. By now, you've either realized this or you didn't. There's no constant at the end. And that means there's a GCF you can factor out of everything. And that means you got to start with that or you're going to screw this up. If you just copied down 1, 3, 6, 18, you're going to get it wrong. It won't work. The goal is to factor it. You had to factor the x out first. So if you didn't do that, stop, go back, you did it wrong. Go back and factor out the x. Because it won't work. The only way you could do it is if you had a 0 placeholder and you knew how to use that. That's complicated to do. So that's your first step in factoring. You know, my prime directive is if you can factor it, you should. So then the first step of factoring is look for a GCF. Cooper, can you tell me what numbers go across here? 1, 3, 6, 18. How come you can do it now because you factored the x out? And you got to remember that you factored the x out at the end of the problem. Because at the end of the problem, I'm going to ask you what's the factored form, and if you don't have an x in front of it, you'll get it wrong. So you might think, well, I did it, I was fine. If you didn't factor the x out here, you won't put it in your final answer. That happened to tons of kids on the first try on this test. Do you have to put plus 0x? No, you don't. Okay. But if you left that as your final answer, you're wrong. And that's why we had to get the x factored out at the beginning. That guy has to come down here. And again, I can prove you're going to be wrong because this kind of question will ask you what are the real answers and what are the imaginaries. And if you don't include an answer for this, you wouldn't have enough answers. Because see, since this is a to the fourth problem, you have to get 4 answers when you add up all the reals and imaginaries. All right, so take a second. This is another skill. Can you tell me what the real and imaginary answers are? And of course, the imaginary ones include I in them. Let's practice that. So today's the hard day. Tomorrow we have a lot more time for individual questions. The real ones are pretty easy. X plus 3 equals 0. And you might be like, I just did it in my head. Okay, fine. But did you actually end up with x equals negative 3 like I did? Because if you just said negative 3, you're going to get it wrong. You need to say x equals. On this one, you can follow the pattern, which is that equals 0. X equals 0. And then you solve it, and it's already solved. X equals 0. And then this x squared plus 6 equals 0. My squared got really weird there. Gonna try that again. And then x squared equals negative 6. And then you square root. Did you remember the absolute value? I root 6. And why we need the absolute value? Because if you write this, you will be smart enough to know x is not alone yet and that you got to get 2 answers. Because see, if all you do for the imaginaries is I root 6, you just lost the whole point for the whole problem. If you haven't noticed yet, we don't give partial credit in this class. So on a test, be like, oh man, they were so close. Math rewards careful people. You get 2 answers, plus and minus I root 6. And that comes from this coming out to a plus and a minus. There you go. All right. Third kind we got to talk about. The graph looks like this. It bounced at 5, then it cut through at 8. The other spot is supposed to be 0, 0 right there. What's the equation for this graph? Remember, there's some that are squared. There's some that are to the third. And there's 3 places it touches, so you need 3 sets of parentheses. Pause, we'll give this a try. All right, so I had a question. My degree's coming out odd. How come both ends are going down? All right, well, that's a really good sign that this kid checked their lead term, and this kid got an x to the third for their lead term, and that's not right. So they know something's wrong because it's not to the third power. It's not even an odd power. It's an even power. And doesn't it have to be an even power for the lead term? Yeah, because they're both going down. So that's really good that you noticed that. But now the challenge is, you know you did something wrong. So what might you have done wrong? Well, your power on one of these, it's to the third. I looked at your answer quick, and you're really, really close. So would you agree that the one that's going through 0, I could say x plus 0, and it's to the third? Did you notice that that was to the third? Okay, good. And then this other one's at 5, so you go x minus 5, and you put that, because that's a bounce, that's squared. Okay? And then the last one, you have x minus 8. And that one, that has a power. 1. Add them up. Comes out to x to the 6th. And since that is even, and it's positive in front, then I know I did it wrong. Why did I do it wrong? Because it's going down on the right. And it's positive in front. You see how I caught my mistake? Because I checked it. And I know that if it's going down on the right, it's supposed to be negative in front. And so then I need a negative right here. Who were the kids that remembered the negative? Only 8 of you or so would have gotten this question right. It's so easy to forget, isn't it? It's going down on the right. It has to have a negative in front. Okay. Math is so picky. Yes, the real world math is picky. You make a mistake, it's wrong. And I forgot the negative, so at least I caught it, because I took a second to check my lead term. And I checked the front of it, and I checked this. Okay. Now, I need honesty here. How many of you feel like you've completely got this? And that means you nod. If you don't completely got this, you should shake your head. So, give me an answer. All right. And there's several people saying they don't completely got this, so we're going to try one more. All right. So, we're going to go bouncy, bouncy, going down. This one's bouncing at -3. This one's bouncing at 2. And then it's going through the 5. Let's try just one more like this. Write an equation for this one. It's hitting there and going through 5. There. Pause for a second. So we practiced this one more time because there was a bunch of kids that wanted one more try on this. Negative, because it's going down on the right. Parenthesis, x plus 3, and that one's bouncing, squared. This one tells me a x minus 2, also bouncing. And this one's a 5, x minus 5. Just passing through, though. Power of 1. If you're smart, you'll take a second and go, y equals negative x to the 2, 4, 5. That's my lead term. And does it match up? Negative, because it's going down on the right. Cool. 5, the ends are going opposite directions. They are. Cool. All right. And the next kind. x to the fourth minus 5x squared minus 6. What are the imaginary roots? What are the imaginary roots? If it feels like these are a lot of really hard problems, it is. I'm going over the hardest kind. Okay, so if you were completely stumped, you should always fall back to my rule, which is if you can factor it, you should. So you get it factored to x squared and x squared, since the last number is negative, plus and a minus. And then it's probably going to be a 6 and a 1. I'll double check it though. 1x squared and negative 6x squared. Does that make negative 5? It does. Yay. And which part gives me the imaginaries? That part. How do I know? Because if I solve it equals 0, I end up very quickly getting a negative that I'm going to square root. And that means absolute value of x is I, and that tells me two things. X equals I, x equals negative I. There's my two imaginaries. Who had those right? I'm curious. It helps me know if we should practice more like that. Okay, cool, thank you. All right, so what else is there? Well, if I just asked you, all I asked you was what are the possible roots? Would you please tell me what the possible roots are? The possible roots. Not the actual roots, the possible roots. Did you remember F count over F code? Factors of the constant. 1 and 2 and 6, plus and minus all that. And factors of the coefficient is just 1. So then it's just these. It's dividing by 1 doesn't change them, right? Okay.
I forgot the 3, I think.
Oh, 3 does go into 6. Thank you. Good catch. 1 and 2 and 3 and 6. Okay, good. Now, notice it didn't catch that there was a negative, or sorry, that there was an imaginary roots. We just found these roots. How come they're not on the list? Because it's possible real roots. It won't find imaginaries. Okay, and then the last melon. And then we have work time. So try this one, and I want to warn you, lots of chances for little mistakes in this one. So be very careful. 3x minus 12 over x squared minus 3x minus 4 divided by 4x squared plus 12x over x squared plus 3x. I'm going to pause for a sec while you simplify this thing all the way down. When you're done, would you just check with the kid next to you? Start here. 3 factors out, add x minus 4. This bottom part factors x and x. Since the last number is negative, it must be plus and minus. It's going to be a 4 and a 1. And the x minus 4s cancel. Yay. Times. This part goes up to the top, and I'm going to factor it. This part will go down to the bottom, and I'm going to factor it. Now, here's a really common oops. People just, some reason, they just don't see these two, and those two cancel. Final answer, 3 on the top. Nothing else up there. And 4 parentheses x plus 1. Could you multiply it out? Yeah, but if you can factor it, you should. There we go. Okay, now you got a bunch of work time. Now, the worksheet for today is unusual. If you did what you were supposed to do last night, you already did a whole bunch of math. Today's worksheet, it's so huge that if you did all of that, it would just be unrealistic. Like, I don't think you're going to have time to do all of that. So, I want you to do several problems, and you pick, and you should pick ones that scare you. I know, you can do easy ones. I can't stop you. You should want to do well on your test, and you should want to practice the ones that are scary for you. So, pick several difficult problems that you know would be good for you to practice, because you kind of suck at that kind, and that's your homework. Do several difficult problems from the new worksheet. Okay? All right, now you got a bunch of work time. Please come up and ask for help.